In order for us to explore the documentation and testing process, we're going to start off with a fairly simple piece of code that's very similar to the currency converter that you might have created earlier in the week.
So there it is. So the next thing we want to do is we want to be able to document the stuff that's here. And the simple way to do this, so there are multiple types of documentation. And these are discussed in the notes for this. So if you look at the Python Quick Start Guide, there's a bunch of stuff in there. But essentially, you can split it into two key types of documentation. One of them is the very fine-grained documentation that talks about why the code is as it is, right? So there are things that you might do and go, well, current exchange rate, it's not really a lot to explain in here. And off we go. So we can put these comments in, and those are only there for anyone that's viewing the source code. So it's for us when we look at it again. It's also for anyone that might have to maintain our code or wants to contribute to the code and things like that. So that's one form of documentation. But another form of documentation is one that is, again, could be for us, but is also for people that might use our code even without looking into it. Okay, now this happens more than you think. But also quite often we want to just document it for the other people in their team. So let's say, for example, you happen to be working on a privilege escalation and remote exploits tool, which you will do by the end of this module. You're going to work in teams and you need to write your own code. You're not going to be assessed on anyone else's work, but you need to use other people's work and they need to be able to use yours. Right, so there you want documentation that's about what this function is going to do if you call it, what you should expect from it. And what we do with those is we put them in something called doc strings. So we would do a string at the start. Now, you can do it like this, put some doc string in. We tend to use triple quotes, and we haven't seen these yet, but triple quotes are a valid way in Python to write a string. And what it means is that we can have a string that has multiple lines. Okay, so I'm going to take that out and just give you an example of this. So if I say data equals 1, 2, 3, like this, and I run it, I get all of the formatting. So what it's doing is it's allowing me to go off the end of the line. Yeah, I can have it's called a multi-line string. I can have multiple lines in it. I can even have quotes in it.
You've got them all singing it now.
And I can mix quotes. Doesn't matter. The only thing I can't do is include another triple quote. So that's what they are. So you could write your comments in single quoted strings, but quite often we want to put these doc strings in multiple lines. So you normally have one line at the start, which is the basic thing. So we might do converts GBP to USD, fairly obvious. And then we can go down onto other lines. And what we would do is we would say arguments, and we put in whatever the arguments for this are. Arguments being what values we put into this parameter list. Okay, so we're going to put in value, and it is the amount of GBP to be converted, and then returns, and we put in what kind of thing it returns. So it's going to be a number. Like this. Okay, so that would be a sort of doc string. And you look here, it's what, 2 lines of code, and we've ended up with 5 lines of documentation. That's not usually the case, but even if it is, it stops someone having to look in and work out what those things do, because we can give them a nice standard description of how this stuff works. So how do we view this? Obviously, you can look at the code, but that's not the point. The point of having this kind of documentation is that it can be read like a document without looking at the code. Okay, so how do we generate it? Well, what we're going to do is we're going to use a tool called PyDoc. No, we're using PDoc. What did I say we're going to use? I've forgotten. PDoc.
PDoc, yeah.
Okay, so oh yeah, that's why, because we're doing virtual environments as well. Okay, so We can use pip, so we can install pip and we can use it, and there's notes on this and what it is. So just to quickly recap, if you haven't already looked through, pip is the package manager for Python. It allows you to install Python modules for things that you might need. Right, there are thousands of these things, so you don't want them all installed, but sometimes you want a particular one. We can install this stuff at the OS level. So pip3 is almost certainly installed on the VM that you're using because it's the same as this one, or was the same as this one. And we can use it like this. We can do pip3 search. If we look for stuff, and then you can see it's got p.3, so we can install it with pip3 install. But quite often when we run multiple projects, we have lots of different things that we need, and they're only needed for that project. Sometimes we have very specific requirements. We need a particular set of things, but we don't want that to be installed on the main system because they need a different set of things which might be incompatible through version numbers or just implementing the same kind of features that mess stuff up, right? So what we do is we make a little virtual environment. If you remember, we used which before. If I type which Python, it tells me that it's running user bin Python. If I did which pip3, it tells me it's running user bin pip3. And that means that this is using the system-wide installation of these things. Just to take you back to here, just to show you. If you go to the quick start, which you can get a link from here, development environment, pip explains how pip works. So really basic stuff. Virtual environments explains how the virtual environment, which is what we're about to do. Files and execution is the stuff that we did last week and you've been seeing again this week. So just pointing out that those things are all there in case you haven't spotted them. So we're going to make a virtual environment, and we're going to do it for this particular little project. Okay, and then we're going to install into that virtual environment the things that we need, like p.3. So over here in the virtual environments, you'll see there's an explanation of how these things work. So Python 3 -m venv. Okay. Python. In this case, we can just do Python because it is Python 3, but just to make sure we're doing the right one, Python 3 -m venv. That means we're going to use the module called venv, which is there and installed already, and we're going to make a virtual environment, and we're going to give it the name of the place we put it. Now, I have a slightly bad habit of I call all of my virtual environments venv. Okay, it doesn't really hurt, except sometimes it would be nice to have them call something different, particularly in Z Shell when it shows you on the command line which one you're in. So I'm going to try to be a little bit more descriptive with them. So I'm not going to call this one venv. I'm going to call this one venv. What happens? Well, looks like nothing, but there's a general rule in Unix-like environments like Linux that if there's no output, things succeeded. Okay, so unless there needs to be output, no output means a success. You should be able to see now there is a new directory called curvenv. If I look inside it, a bunch of stuff. Okay, what's in there is a Python interpreter and all the modules that would be there by default. So things that you might need, the base install of Python. I want to use that, right? So at the moment, remember, Python is using the system-wide Python, user bin Python. I want to activate this virtual environment, which means inside this terminal, this shell, okay, let's do that again. That's interesting. I will now be using a different Python interpreter, and when I install things, they'll be installed inside that virtual environment. So to activate it, I can either type source and then where I want to get the stuff from. So it's always going to be the name of the virtual environment. So curvenv bin activate, or I can just put dot, okay, which means the same thing. So dot space and then the path, which is // meaning here, curvenv /bin /activate, always the same. Okay, and you can see, because I'm in Z Shell, it actually shows me on screen that I'm currently inside that virtual environment. You look at the command prompt previously, didn't include it. Look at it here, it now is included. And this is good because if you have two terminals open and they're in different virtual environments, it will tell me which one I'm in. And that's why it's actually a good idea to name them something sensible rather than just do what I normally do and call them all venv, and then I know which one you're in. So if ever you're not sure, you can always do which Python and it will tell you, right? So remember, which Python before was user bin Python. Now it's home student week 2 curvenv bin Python. So we have our own Python. Which pip? Well, now that's going to run from inside there. Same as pip3, but it's going to be the same thing now. And that's why before, when we didn't have pip, there was no pip installed for Python 2.7, and there was only pip3. There's no alias to pip in the main system, but there is inside here. So we're inside a virtual environment. Okay, so pip search pdoc3. Yep, that's there. So pip install pdoc3. Now this will actually download the files that we need and install them. Don't worry about it building the wheel. It's really not important. It's not a failure. It's just failed a step that it likes to do, and it's not at all an issue. So we could fix it, but it's just installing packages that we have to explain for no reason. Okay, so what's happened? Inside curvenv. No, curvenv, there we go, that's the one. And inside lib, and inside Python, and inside site packages, you can see a bunch of stuff that was installed by default, but also now you can see pdoc3. Okay, so as we install, this is where that will go to. And also, if I look, well, where is pdoc3? It's inside there. Okay, so that now will run. If I'd installed it with pip without doing the virtual env, it would have been installed on the main system, which could be what you want. I mean, that's not a problem as well. But yeah, we're going to try and use virtual environments for a lot of this because you'll have different requirements for different projects. Okay, right. So let's try using pdoc3. So pdoc3 on currency.py now shows us the documentation for that. There's only one function in there, but here's the documentation. Okay, so there's the functions. As we get more stuff that's in there, this can get more complicated, but it can show us that documentation. It will do more than that, though. Okay, so do pdoc3 -- help will give you some more of the options, so you can see it does a lot of stuff. This is the one that I'm going to show you now, although actually the PDF one's quite good as well. -HTML means that it will output this as a HTML document. pdoc3 -HTML currency.py, and now there's a HTML folder, sorry, directory, and inside there is a currency.html file. If I load that in Firefox, you can do in a few ways, but I'm just going to open up a new tab, go to file : / and then I can type in the path to where something is. So it's going to be /home / student, and to be honest, that's enough, and you can then just browse on there if you want to. Normally I type it all in, but I think it's probably a good idea to show you an easier pointy clicky way to do it if you're not used to remembering all the path names. So I'm doing stuff now in what does I call it? Week 1, week 2. I forgot which week we're on. And HTML, and there it is. And you get this nice view of what's there. If there's more than one function, more than one class, and things that need to be documented, then you click and it will take you directly to it, so you can see where things are, highlights the stuff. And there it is. If you want to, you can even see the source code that goes with the stuff that you're doing. So here you can see the source code for the whole module. Here you can see the source code for the function. And so this is a much nicer way for you to look at how something's expected to work, review the code and do stuff. You're going to be doing this for your projects all the way through, because it's one of the most useful things about Python is the way you can make this nice So self-documenting code and have systems that work with it. If you're using other languages, not for this module, but in other places, there are equivalents for almost everything. There are even sort of fairly standardized things. So if you wanted to do something in in other languages and stick to something standard, you can do that too. There are plenty of people who have preferences for different kinds of documentation, things like Doxygen and stuff like that. Okay, so that's our PDoc3 and how we use that. Does anyone have any immediate questions on this before I go on to making some tests?
One of the questions that's come up a couple of times is they understand what you're doing, but they're not sure why VMs are so important.
Okay, it's one of those things that will become much more obvious as time goes on, because you'll start to install multiple bits of software. So we'll get on to, say, Transcoder in a minute, but if I just show you that now, so Transcoder, what I've got in here is a list of requirements. So PDoc3, PyTest, colored, which is for doing colored output, and wheel, and then I can use pip install -r and then a list to install all of those requirements. Now, when that gets bigger and bigger, you don't necessarily want to keep saying to people that run your code, oh, by the way, you also need on your system to install this, 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 and this, because that might not work for them. Okay, that might conflict with other things that they need. They might not be able to use the latest version of something which you need because they've got older dependencies and so on. So what, with the VM, you can say that's fine. You can just put all this in one place, and when you run that program, it'll use the stuff from inside there. So it's a neat way to keep that stuff packaged up. It also means that your development environment can be portable and move from place to place without actually having to affect the wider system. So you'll notice with things like Transcode, when we get to that, you download it and then you can install and make everything without actually having to be root. You can install it just inside a user area and build the stuff on there. And if you want to delete it, you can do. You're not going to delete stuff that other people require because it's all inside your own area.
I'm going to add another slightly less obvious advantage of it, but this has bitten me before. It makes it really easy for your testing. Because if you're using the global, so if you have things installed as part of your system, then I've done this many times before. You do import X, you forget about it, and then when you give your software to someone else, they're missing that library, so they're not able to do it. So a virtual env is a really nice way of making sure you've got all your dependencies in place and you can test that everything works, out of a box. Because I've been on site with things. I've been on site without internet installing software, and been missing a dependency, and there were quite a few choice words said when I realised that I was missing that particular piece of software because I thought I had everything on a USB stick. So
yes, that's a good point. Okay. So the next thing we're going to do is we're going to run. We're going to make some tests. Okay. So I've got this sort of example here that I used on the multiplier. So I'm going to switch over to that one. So you can see I've already got some documentation built in for this one. So it's very similar to the last stuff we did. Because I just realised I want you to do the currency converter, not me. So I'm moving over to this one. And what I've done is I've just made a function called test multiplier. And that has what we call an assertion, which says this thing must be true. Okay, so multiplier 3 equals 10 must be true. Now you might be thinking, hold on, that's not right, but just bear with me. We'll get there in a minute. All right, so that is the test. So it's a function. It starts with test underscore multiplier. It has an assertion in it. That assertion is just something that must be equal to something else. Okay, now double equals is important. If you use single equals in single equals in Python, it thinks you're trying to assign something. So if I said a equals 12, I'm saying I want a to be equal to 12. A double equals 12 is testing to see if they are equal. Okay, right. So let's try that out. For this, we want PyTest, okay? And again, it's not installed because we're going to install it inside the virtual environment. So pip search PyTest. Okay, you see actually a load of stuff for this. It's a really good testing framework. So PyTest is what we need. There's a ton of stuff. So you can see HTTP server. So if you need to run stuff that over HTTP, you can still write tests for it. You can write tests that use all kinds of like really fancy stuff. We don't need any of that for the moment. Okay, all we need is the basics. So pip install PyTest. Again, goes through, installs. Pull that back into view. Now when I do which py.test, so so it's again, I'm doing things without explain. Rehash. If you're using Z shell, actually I might have explained this last week. You install new programs. The tab completion doesn't necessarily update straight away. If you know you've just done something, it's not tab completing, then typing rehash will renew all of the completions. So py.test is what we expect to have, and we can tell that's coming from inside the view. Now I'm going to run it. So py.test and the thing we want to test, which in this case is funcdemo2. And you can see it runs the test and it fails because, well, it's going to, because 9 is not the answer to this. So sorry, 10 is not the answer to this. So change it to what it should be and run it, and it says 1 test passed. Now we can have many of these tests. So here I'll give you an example of just one, but we can also do things like, well, you know, what happens? What about if we've got negative numbers? All right, so -3 should be equal to that. We can also have multiple assertions inside each one. So -3 times -3 should be equal to 9. Yeah. So test, and it says it's passed 2 tests. So that's this one and this one. And this one has 2 assertions in it, but they are still 1 test. And I think -v is probably the other thing that you want, where it will show you in more detail what it's done. So you can see test multiplier, test next, passed. Okay, you get a percentage. Let's just put in there one of these things that's going to fail. Okay. You can see, let me clear the screen. You can see as it goes down, you get to here, and then you can see the fail, you can see the detail. If you take that bit off, you only see where it fails. So it tells you that it's passed 1 and failed 1. So the -v, just short for verbose, and it gives you the extended information. Okay, so that's how we run these tests. Later on, you'll see how these can be put into separate files. So you'll see that's part of transcoder, but it works in the same way. Okay, so you don't have to have them polluting your code, kind of just being tidy. It's good to have them in a separate place. So you know your code, you know, is just what you need to get stuff done. It has its nice documentation, and your tests you put somewhere else. Okay, so you can work on those separately, and they're not in the way when you're trying to debug things and work out what's going on. But for small stuff like this, in the same place is fine. Just again, going through here, you've got the stuff about installing various things, so remember that, and the test stuff is the 2 things that you need. And I think yeah, so you've got pip search, pip install for doing that. And so what I'm going to do, actually I'll do that now, is I'm going to put this onto Pastebin, same as before. Oh, top result. So we'll put that in there, and then I'm going to put at the bottom, just for reference, pdoc3. We run it like this: p.3 minus HTML xyz.py and PyTest, which you run like this. Minus v if you want to or not, it's up to you. xyz.py. So xyz is whatever, whatever your current Python is. This bit on the left is the name of the thing, so that's what you'd look for. That's in pip. This bit on the right is an example of how you might use it. Okay, so Python and we'll call it okay. So that is 6KS capital EZPU capital V. That into here. That's 6KS capital EZPV. Here it is. There we go. Okay. Any questions? Adam, have we got anything stacking up?
No, nothing. Everybody seems to be following along fine.
Awesome. So this one, there's some fiddly bits, because you've got to remember, how you call the functions and stuff, from outside. Sorry, how to call the tools like p.3 and py.test.
But they're given to you in the paste bin.